Hey guys, welcome to my channel. Today you will see 10 most durable metals on Earth. Of course you can't buy most of them, but you should know about their existence. Take your sit and let's get started. Number 10. Beryllium. Beryllium is a steel gray, strong, lightweight and brittle alkaline earth metal. It is a divalent element that occurs naturally only in combination with other elements to form minerals. Notable gemstones high in beryllium include beryl and chrysoberyl. It is a relatively rare element in the universe, usually occurring as a product of the spallation of larger atomic nuclei that have collided with cosmic rays. Within the cores of stars, beryllium is depleted as it is fused into heavier elements. Beryllium constitutes about 0.0004% by mass of Earth's crust. The world's annual beryllium production of 220 tons is usually manufactured by extraction from the mineral beryl, a difficult process because beryllium bonds strongly to oxygen. In structural applications, the combination of high flexural rigidity, thermal stability, thermal conductivity, and low density make beryllium metal a desirable aerospace material for aircraft components, missiles, spacecraft, and satellites. The ninth place in our top is occupied by titanium. It is a lustrous transition metal with a silver color, low density, and high strength. Titanium is resistant to corrosion in seawater, aqua regia, and chlorine. The element occurs within a number of mineral deposits, principally rutile and ilmenite, which are widely distributed in the Earth's crust and lithosphere. It is found in almost all living things, as well as bodies of water, rocks, and soils. The metal is extracted from its principal mineral ores by the Kroll and Hunter processes. The most common compound, titanium dioxide, is a popular photocatalyst and is used in the manufacture of white pigments. The two most useful properties of the metal are corrosion resistance and strength to density ratio, the highest of any metallic element. In its unalloyed condition, titanium is as strong as some steels, but less dense. Number 8. Uranium. Uranium is a silvery gray metal. Weiss is weakly radioactive because all isotopes of uranium are unstable. The half-lives of its naturally occurring isotopes range between 159,200 years and 4.5 billion years. It occurs naturally in low concentrations of a few parts per million in soil, rock, and water, and is commercially extracted from uranium-bearing minerals such as uraninite. Many contemporary uses of uranium exploit its unique nuclear properties. Uranium-235 is the only naturally occurring fissile isotope, which makes it widely used in nuclear power plants and nuclear weapons. Also, it is characterized by a rather heavy weight, is widespread everywhere, and has paramagnetic properties: flexibility, malleability, relative plasticity. Number 7. Chromium. Chromium is a steely gray, lustrous, hard, and brittle transition metal. Chromium is the main additive in stainless steel, to which it adds anti-corrosive properties. Chromium is also highly valued as a metal that is able to be highly polished while resisting tarnishing. Polished chromium reflects almost 70% of the visible spectrum, with almost 90% of infrared light being reflected. The name of the element is derived from the Greek word chroma, chroma meaning color, because many chromium compounds are intensely colored. Chromium metal is of high value for its high corrosion resistance and hardness. A major development in steel production was the discovery that steel could be made highly resistant to corrosion and discoloration by adding metallic chromium to form stainless steel. Stainless steel and chrome plating together comprise 85% of the commercial use. 6th place. Tungsten. Tungsten or wolfram is a rare metal found naturally on Earth almost exclusively as compounds with other elements. The free element is remarkable for its robustness, especially the fact that it has the highest melting point of all the elements discovered, melting at 3,422 degrees Celsius. Polycrystalline tungsten is an intrinsically brittle and hard material, making it difficult to work. However, pure single crystalline tungsten is more ductile and can be cut with a hard steel hacksaw. Tungsten occurs in many alloys, which have numerous applications, including incandescent light bulb filaments, X-ray tubes, electrodes in gas tungsten arc welding, superalloys, and radiation shielding. The 5th place is taken by rhenium. It is a silvery gray, heavy metal. Rhenium is one of the rarest elements in the Earth's crust. Rhenium has the 3rd highest melting point and highest boiling point of any stable element at 5,869 Kelvin. Rhenium resembles manganese and technetium chemically and is mainly obtained as a byproduct of the extraction and refinement of molybdenum and copper ores. Discovered in 1925, rhenium was the last stable element to be discovered. It was named after the River Rhine in Europe. Nickel-based superalloys of rhenium are used in the combustion chambers, turbine blades, and exhaust nozzles of jet engines. The 4th place. Tantalum. Named after Tantalus, A villain from Greek mythology, tantalum is a rare, dark, dense, very hard and blue-gray, lustrous transition metal that is highly corrosion-resistant. It is part of the refractory metals group, which are widely used as minor components in alloys. The chemical inertness of tantalum makes it a valuable substance for laboratory equipment, and as a substitute for platinum. Its main use today is in tantalum capacitors in electronic equipment such as mobile phones, DVD players, video game systems, and computers. Tantalum, always together with the chemically similar niobium, occurs in the mineral groups tantalite, columbite, and coltan. Tantalum is considered a technology-critical element. The metal is renowned for its resistance to corrosion by acids. In fact, at temperatures below 150 degrees Celsius, tantalum is almost completely immune to attack by the normally aggressive aqua regia. The top 3 liters is opened by ruthenium. It is a rare transition hard white metal belonging to the platinum group of the periodic table. Like the other metals of the platinum group, ruthenium is inert to most other chemicals. Ruthenium is usually found as a minor component of platinum ores. The annual production has risen from about 19 tons in 2009 to some 35.5 tons in 2017. Most ruthenium produced is used in wear-resistant electrical contacts and thick film resistors. A minor application for ruthenium is in platinum alloys and as a chemistry catalyst. A new application of ruthenium is as the capping layer for extreme ultraviolet photomasks. Ruthenium is generally found in ores with the other platinum group metals in the Ural Mountains and in North and South America. Second place takes osmium. Osmium is a hard, brittle, bluish-white transition metal in the platinum group that is found as a trace element in alloys, mostly in platinum ores. Manufacturers use its alloys with platinum, iridium, and other platinum group metals to make fountain pen nib tipping, electrical contacts, and in other applications that require extreme durability and hardness. The element's abundance in the Earth's crust is among the rarest, with an abundance of only 50 ppt in the Earth's crust. It is estimated to be about 0.6 parts per billion in the universe and is therefore the rarest precious metal. Also osmium that remains lustrous even at high temperatures, and it has a very low compressibility. With a small margin, iridium takes the first place. Little mark. Iridium and osmium are almost equal in their density and both are one of the most durable metals in the world. But let's go back to iridium, a very hard, brittle, silvery white transition metal of the platinum group. Iridium is considered to be the second densest metal, after osmium. However, at room temperature and standard atmospheric pressure, iridium has been calculated to have a density higher than osmium measured the same way. Still, the experimental X-ray crystallography value is considered to be the most accurate, and as such iridium is considered to be the second densest element. It is the most corrosion-resistant metal, even at temperatures as high as 2000 degrees Celsius. Although only certain molten salts and halogens are corrosive to solid iridium, finely divided iridium dust is much more reactive and can be flammable. The most important iridium compounds in use are the salts and acids it forms with chlorine, though iridium also forms a number of organometallic compounds used in industrial catalysis and in research. Iridium metal is employed when high corrosion resistance at high temperatures is needed, as in high-performance spark plugs, crucibles for recrystallization of semiconductors at high temperatures, and electrodes for the production of chlorine in the chloralkali process. Iridium radioisotopes are used in some radioisotope thermoelectric generators. Iridium is found in meteorites in much higher abundance than in the Earth's crust. For this reason, the unusually high abundance of iridium in the clay layer at the Cretaceous-Paleogene boundary gave rise to the Alvarez hypothesis that the impact of a massive extraterrestrial object caused the extinction of dinosaurs and many other species 66 million years ago. Similarly, an iridium anomaly in core samples from the Pacific Ocean suggested the Eltanin impact of about 2.5 million years ago. It is thought that the total amount of iridium in the planet Earth is much higher than that observed in crustal rocks. But as with other platinum group metals, the high density and tendency of iridium to bond with iron caused most iridium to descend below the crust when the planet was young and still molten. That's all. Thank you for watching this video. Leave your comments, subscribe, and see you later. Goodbye.